In this video, we're going to talk about geometric integrals, which doesn't mean anything to you right now, so we have to define them. So previously, we saw that finding the area under a curve will have some benefits. Again, it might seem like a weird thing to do at first, but we saw that if we have a velocity graph, the area under a curve tells us stuff about the position. All right, so now we're going to give it a name and notation. So the name we're going to give it, we're going to call it the integral. I actually spelled it wrong on the slide introducing. That's pretty bad. So integral is the area under the curve of the function f of x. All right, so the area under the curve is the integral. So every single time we say derivative, we think slope of tangent line. Now every single time we say integral, we're going to think of area. And the notation looks like this. So this curly S type thing, it's kind of an elongated S, represents area. And it's the area from A to B. All right, so this kind of gives us the edges of our area. And the function that we're taking the area under is f of x. And this dx part will be in all your integrals. It just tells me kind of the variable that I care about. Since I'm doing area kind of in this direction, that's the x direction. That's what the dx means. This isn't important, but you could do it this way, and then it would be dy because that's in the y direction. All right, so this is our first problem using this new notation. So we're trying to find the area from 0 to 12 underneath this function. All right, this function, it's not the whole shaded thing, it's just the solid part. But you can see the shaded region is what we want because that's the area underneath that kind of diagonal line. All right, from 0 to 12. All right, well, we'll learn sophisticated ways to do this in the future, but for right now, we can just see these are three triangles. And we know the area of a triangle is 1/2 base times height. So this area is going to be the area of the first triangle, which is 1/2. The width is 2. The height is 2. Plus the area of the next triangle, 1/2. The base is 4. The height is also 4. And plus the last triangle, the width is 6 to 12 is 6. And the height is 6. So that's 1/2 times 4 plus 1/2 times 16. 1/2 times 36. And we get 28. All right, so we're going to have to, of course, learn more difficult ways to do this, but as long as you know that this symbol represents area and you can find some basic areas, you're going to be fine. All right, one more example. All right, this looks pretty much like the same thing. The only difference is when we're talking about area, this is a really weird thing in calculus. Area can be negative, and because it has applications of things like you can be going to the left or the right when we're talking about velocity, and that'll affect your position. Actually doing negative area makes sense in these contexts. So when we're figuring out this one, we just figured out that this triangle has area 2, this one has area 8, and this one had area 16. No, sorry, 18. But when we go to add up these different triangles now, we're going to take 2, that's the area of that first triangle. We're going to subtract 8 because this is a triangle, but the triangle is below the x-axis. So any area under the x-axis is going to count as a negative area, and then plus 18. So that's 20 minus 8 is 12. So the area under this one is only 12, even though it's the exact same shapes as the previous example. We're going to say that areas under the x-axis are negative. All right, so this is the important thing to get from this example. All right, here's one for you to try on your own. Same idea, different shape. So you just have to know how do you find the area of these shapes, find the area, add them together. All right, so I'll show you the answer for this one in 3, 2, 1. And the final answer I got for this one is 7 pi. So these are semicircles, so the area is pi r squared, and then divided by 2 because it's only half a circle. The radius of this one is 1, 2, and then 3. All right, so plugging all that in, simplifying a bit, you get 7 pi as your area. All right, so here are the important things for this lesson. All right, just remember now we have this new thing called an integral. It has a symbol, which is kind of an elongated S, and it represents finding an area. So every single time you see that, think of area. It'll have some other things as well, just like derivatives are some other things other than just the slope of the tangent line. But the first thing we're going to think about is area. And then the new thing in calculus, negative area actually does make sense when given a context.